So in this video we are discussing building a simple text classifier in PyTorch. So uh, we're going to build a basic um, natural language processing classifier using PyTorch. The goal is to classify text into categories like spam versus non-spam, positive versus negative sentiment, fruit recipe versus vegetable recipe. So um, this video specifically uses the recipe titles and predicts whether the recipe is about fruit or vegetable. So here's the big picture in pipeline. The full classifier follows three major steps: from the text to embeddings to polling to output layer and prediction. Think of it like from the apple pie recipe, it converts words into vectors. After that, it combines vectors into one sentence representation and predict category. So step 1, embedding layer. Words cannot directly enter neural networks. Computers only understand numbers. So we convert words into vectors, like a list of numbers. Like for example, the apple is represented of the vectors and consists of the list of numbers like 0.2, negative 0.5, 1.1, so on and so forth. And the same as banana, like that, is equivalent to the list of numbers. This process is called embedding. So in PyTorch, we use the code and end that embedding. Instead of the parameters, we have the vocab size, which is total numbers of unique words, and embedding stem is the size of each word vector. So, like for example, vocabulary size is 10,000 and the size of each word vector is 128. So, meaning we have 10,000 unique words, and each word becomes a vector of size 128. So, why embedding matter? Embedding helps the model learn relationships between words. Like for example, the apple is a fruit-related region in the vector space, and banana is near in apple. Carrot is farther away. The network learns these positions during training. So step 2 is pooling. A sentence contains multiple word embeddings. Example, I love apples, and its embeddings, vector is I, vector love, vector apples. But the classifier needs one vector for the entire sentence. So we combine them using pooling. So what does mean pooling? Average all vectors. Like for example, we have the vectors like having a 1, 2, the first vector, and the second vector is 3, 4, and the third vector is 5 and 6. So we average those, and like example, the 1 plus 3 plus 5 divided by 3, and the second index of each vector is 2 plus 4 plus 6 divided by 3. So if we could average it, we could have ends up to 3 and 4. So why it's good? It's stable, it's simple, it treats all words equally. This is often the best based on model. So what is max pooling? Take the maximum value from each dimensions. Like for example, if we have the first vector of 1, 5, the second vector of 3, 2, and the third vector is 4 and 5, the result would be 4 and 8. That's because the maximum value from dimension. So why good? It highlights the strongest features. Useful when certain words or keywords are very important. Like for example, the terrible, the amazing, the hate. These strong words dominate classification. Next is sampling. Adds all embeddings together. Why useful? It preserve frequency information. Like for example, apple and apple and apple. The repeated word has stronger influence. Step 3 is output layer. The output layer is after pooling. Sentence vector. After the sentence vector, we have the linear layer. After that, we have the linear layer is the predictions. In PyTorch, we have the NN linear, We have the embedding dimension and number of classes. Like for example, the embedding dimension is 120 and the number of classes is 2. So the output would be, like for example, 2.3 and negative 1.0 vector. So these are called logits. Here is a softmax. It converts the logits into probabilities. So like for example, we have the score of the fruit of 0.921 and the vegetable is 0.09. So now the model predicts its fruit because it's the highest one. What is an embedding bags? PyTorch provides a shortcut. So an embedding bag, instead of embedding and manual pooling, it combines both into one layer. Why embedding bag is so powerful? It's faster, it avoids creating large intermediate tensors, less memory usage, better performance. Next is simpler. No need to manually code the mean, sum, max. Everything happens internally. So how embedding works? Embedding bug works. So we have the input token IDs and offsets. Example, if we have the tokens 1, 2, 3, 4, 5, 6, and the offsets is 0, 3. So the meaning, the sentence 1 we have tokens from 0 to 3, like that. Start from 0 and start to 3, and the next the sentence tokens is 3, 6. So embedding automatically looks up embeddings, pulls them, returns 1 vector per sentence. And by the way, the offset is the it's kind of the one with splits, like a split. You could see the token is split together. Like for example, if you set the tokens, I mean the offsets of 0 to 3, meaning it would start from 0 index and ends up with 3, and it would start again in 3, again in 6, like that. So what is dataset pre-processing or pre-processing? Before training, data must be prepared. Pipeline is load dataset. From we load the dataset, we clean the text. After we clean the text, we tokenize, we build the vocabulary, we convert words into IDs, create the data loader. Next, tokenization, converting text into smaller pieces. Like for example, if we have the sentence "I love apples," we could convert into the small phrase like "I love apples." So the vocabulary. So what is vocabulary? Here is we maps the words into integers. Like for example, if we have the apple, its index value is 1, banana is index value is 2, the carrot is index value is 3. Now sentence become to 1 and 2. If we have the sentence apple banana, the sentence become 1, 2. So what is padding? Sentence have different lengths. Example 1, 2, and 1, 2, 3, 4. Neural networks need equal size batches. So we pad it like from 1 to 0 we have 1 2 0 0 0. So it could be to be equalized size to the other one, to the 1 2 3 4. So where 0 is the padding token. Why padding in index 0 matters? So in Python or PyTorch, the NN embedding like that, PyTorch ignores the padding token during training. So fake padding values do not affect learning. The two models. The lesson compares model 1 embedding bug model. So the pipeline is from embedding to spooling to dropout to linear, very efficient. So model 2 is manual pooling model. From the pipeline embedding, we use the man, max, sum, pooling, and dropout, and to linear, more flexible. So dropout layer. If we have the dropout 0.5, it randomly removes neurons during training. So the purpose is to prevent overfitting, improve generalization. If dropout is 0.5, 50% of neurons become 0 temporarily during training. Next is forward method. The forward function defines data flow. Example, if we have the forwards of x, we have this embedding. After that, we have the mean, and we set it the dimension to 1, solve the dropout, and fully connected, and finally we return the value of the input. So meaning, from the input, we embedding, we perform pooling, we perform dropout. After we perform the dropout, we perform the linear layer, and finally the output logits. So here's the hyperparameters. So in the important settings is, if you have the hyperparameter of vocab size, meaning it's a vocabulary words. We have the embedding thing. We have the meaning. It's vector size. The hyperparameter number of classes is output categories, and the hyperparameters dropout. We have regularization string. So why this model is important? This is a foundational natural language processing architecture. Model systems like RNS or recurrent neural network or LSTMS and transformers are all still rely on the idea of from text to vector representation to prediction. A simple model is built in before the advanced architectures. So the important intuition here, the classifier learns from certain words to certain labels. Example, if we have the word apple, likely class is fruit, banana is fruit, carrot is vegetable, spinach is vegetable. During a trading, embeddings improve, pooling summarizes meaning, and linear layer learn decision boundaries. So the full mental model, think of a model like we have the sentence, break into words, convert words into vector, combine vector into one meaning. Classifier predicts category. So the simplified architecture diagram from input sentence to conversation, word IDs, embedding layer, pooling layer like min, max, and sum, and dropout, linear layer, and prediction. So which pooling usually works best? If we have the pooling mean, it's best for balanced understanding. If we have the max, it's strong keywords, and if we have sum, it's a frequency sensitive task. And that's it.